I am just so flattered by this wonderful honor and this really great attention. I'm also really flattered because UTT has decided to focus on the field of nanophotonics, which is really emerging not just as a field for basic science, but also a field for real-world applications. So the entire 2 days has been a real blessing and a very, I'm just extraordinarily honored that this community has decided to do these honors. It looks like I'm working in 5 different areas at once, but there's a tremendous unifying factor to the combination of nanoparticles and light. Ever since the Middle Ages, actually, Troyes is a wonderful example of this. There are beautiful stained glass windows, vitraux, in the cathedrals and the churches here. And many of the colors that were made are basically consist of nanoparticles and light. So one can make beautiful, vivid colors, but also this interaction is incredibly strong. It's very, very important, and it can be used in many different fields. And so part of what we do in research is to understand the basic relationship. What is the fundamental physics between what is the fundamental physics regarding how nanoparticles and light interact? But also, as we discover and as we understand, how can we use and how can we exploit some of these new discoveries directly for many of the applications that we have looked at. Well, we've been able to connect our work from fundamental science to real-world applications in a relatively short period of time. For example, when we hear about drug discovery, we are told that it takes decades for drugs to be discovered and then to be vetted by various governments or organizations so they can be used. But what we have found, depending on field, of course, that the relationship between what we can discover in the laboratory and then how this can be translated into something that's of commercial value, of access to the public, can be relatively short, can be just a few years. That makes it very exciting for students to work in this area, of course. So we built a nanoparticle that absorbs light at a wavelength that passes through the body. And at the time, I was really more interested in building nanoparticles than thinking about what they could be useful for. But I developed a collaboration with an outstanding bioengineer, and between the two of us, we came up with several different applications that relate to biotechnology and biomedicine. And one of them was cancer therapy. And the idea is you can place the nanoparticles into a tumor, or they flow naturally into the tumor if you inject them into the bloodstream. And then after they collect in a tumor site, which is part of the natural cancer biology, then you can shine light through the skin into the tumor, and the particles absorb the light, convert the light to heat, and induce cell death. And it's a very, very effective therapeutic. But it took us some time to go from that idea, which is very general, to then enter the world of cancer, the reality of cancer therapy, which is divided up by organ systems, right? People who do breast cancer, they don't talk to people who do prostate cancer, don't talk to people who do pancreatic cancer. It's very different worlds, and that's the world of medicine. But we were very fortunate that there was a breakthrough in imaging in 2012, and that allowed people to image within the prostate. It's a revolution in terms of our understanding of prostate cancer and our ability to diagnose prostate cancer. And that's actually a topic that was very near and dear to my heart because my father was a prostate cancer survivor. And it's a very, very common cancer. 1 in 9 men will have a prostate cancer diagnosis in their lifetime. And if they have a relative with prostate cancer, that rate rises to 1 in 3. So one of the basic problems with prostate cancer is the therapy itself, because the therapy itself is in many men's minds worse than the disease because it causes incontinence and impotence. And what we have been able to realize in combination by combining our nanoparticle therapy with state-of-the-art bioimaging is a way to very localized focal therapy to treat and to remove tumors from the prostate with absolutely no side effects. So all of the side effects that have prevented men from getting diagnosis in time, that paradigm is just completely gone, right? This is an early stage treatment and the men walk out of the hospital. It's done basically as an outpatient treatment, and they have a normal quality of life. They don't lose sexual function. They don't have the problems with urinary incontinence. It is a game-changing result. And we feel so excited about this. This was not in any way our first idea or our first thought. And it shows you that very often the timing is everything, that one technology needs to stand on the shoulders of another technology in order to realize its full potential. So we think this is something that's going to change prostate cancer forever around the world and will be revolutionary. And we'd love to see this move into other areas of cancer, ultra-localized therapy in, say, for example, retinal cancer or other types of organs where ultra-localized treatment is very, very important, is vital. So, so we're very, very excited about this. Different people have definitions for what curing cancer is. And if curing cancer means it will prevent ever the development of a cancer cell, that is a different field. What we're looking at is when cancer is identified and visible with imaging methods, if it can be removed in a virtually perfect way. If it can be removed without damaging the normal tissue and just one cell over, for example, in the direct vicinity of the nanoparticles. So that's a very, very effective paradigm for therapy. It does not exist for conventional therapies now. Some people would call that a cure, but the cancer was there in the first place, so it's not a preventative cure. These last few days has been extraordinary. This is the first time I had the opportunity to visit Troyes. I just love the history here and the beautiful aesthetics of this town. And you also get a feel that this is a wonderful community. Doesn't feel like a big city. It feels like a wonderful, warm village and community, a town that is, that is more intimate than, say, a big urban center. So I have wonderful memories of not just the people at UTT, but also the town, the city itself, and what great opportunities for learning about history, learning about the country as well, learning about French history has been offering to me.